Hi, now an example for multinomial Logit model. So before the doing regression, we do the data demonstration and some data description. So this example comes from the 1996, the National Election Study. And the data set includes 944 persons. So each line represents a person and their demographic information. So 10 variables. So for example, the first variable is the that person that lives in, and the hours of TV news that they watched, and some other some political variables, and some demographic variables such as age or educational level, and the income, and the which candidate that they voted. And we think about this, the PID, as the response variable, so Y. And this variable PID is basically a categorical variable with 7 levels. So the strong, the democratic, and the weak democratic, and the independent but leaning towards democratic, and so on. So, but just for simplification, we categorize this as democratic and the independent and the Republican. So we have only 3 categories. So originally we have the 7 categories, but we make 7 into 3. And age is and we use the several predictors. So one is the age. So this is just a continuous variable, even though this is an integer, at least numeric. Educational level. So this is the categorical variable with the 7 levels. And income. This has several categories, maybe 24 categories, but it's still categorical. But we will make it the numeric. So basically, this is the income range. So for example, the $3,000 to $5,000. So we just we calculate the center, the 4,000, and then we make it as a numeric variable. So our objective is to regress this Y variables, age and the education and the income level. And we ignore all other variables. And at first, this is how to transform the income variable to numeric variable. So we just at first define so this numeric variable whose values are the center of each category. Actually, the largest one that we don't have a center, but we assume that also the textbook assume that $115,000. And the original variable was original variable is actually the categorical variable. So basically 1 to 24. So first class is here, and the second class is here, third class is here. So if we write the income.n of income, then that means that if income is the lowest level, that choose 1.5, the second lowest level, that it chooses 4, and so on. So we can define the numeric income variable as this. So the capital I, NC or ME is the numeric income level. And level of the PID, the party identification. So we have the 7 categories, but we make the first 2 as the democratic, and the next 3 as independent, and the last 2 as the Republican. So now that we have only 3 categories. Yeah, then now we make a data frame which includes this variable, income variable, and the new PID variable, and the education variable and age variable. So that we now use this data set. So income. So income is already included in the RNES 96 data set. So we erase the original, delete the income variable because the duplication makes some troubles. So this is the data description and some figures. So this is the educational level and the party identification. So educational level, we have the 7 levels. So the first one is the middle school graduate, and this is the high school dropout, and this is high school graduate, and the, I'm not exactly sure, but then this may be the graduate school, something like that. And you can see the maybe it's too small, but the Republican and the Independent and the Democrat from the bottom. So the educational level is lower. We have the more supporters of the Democratic Party, and there are somewhat large supporter of the Independent Party, and the maybe the Independent, the political preference, and fewer the Republicans. But the educational level gets higher, the more Republicans. So people support more Republicans, but at highest level, maybe slightly lower than these levels. Yeah, so another way to put it is using just the line graph. So the curve is here. So as educational level gets higher, then the supporter will increase. And the Democratic Party, the other way around, and Independent, it's in the middle, so it's a little bit vague. So these are beautiful graphs, and the next slide explains how to. Next slide explains how to create those. So at first, we have to make a table. So the party, that we have the Democratic and the Independent and the Republican. So we have 3 categories, and the educational level, we have 7 categories. So we have the 7x3 table. So at first we need that table. So we calculate that table by xtabs function. Then we get this table tab, so 7x3 table. Then we want to make a plot of this. But at first we want to make it as proportions, because these are just counts. So proportion, so we take summation by using apply function. So apply tab 1 summation. So this is the sum of each row. Then we divide, excuse me, we divide the whole numbers by the sum of each row. So tab over summation is the proportion. So we divide these numbers by 13 for the first row, and the second row, so this is the 52, so this over 52, and so on. Then we can make the proportion. So this is a table, again, the 7x3 table. So I truncated several lines. Then to make a graph, that we have to make it as a data frame. So this data frame is basically the 20x3 data frame, so that we have 21 rows. So basically, we originally have 7x3, but we make it as just a 1 vector. So just educational level and the party. So these 2 vectors, they explains the educational level and the party. So educational level, this the middle school, high school dropout, high school up to graduate degree. So we repeat that sequence of 7 3 times. And the party, we have the 7 Democratic. So first 7 is Democratic, and the next 7 is Independent, and the last 7 is Republican. And this is frequency. So if we just write the D as the data.frame of this prop, then it automatically generates this. Then we can use this ggplot function. And then we can create this graph. Oh, actually, I missed this code, but this is the plot function. This is just made by plot function. I will revise the slides later and upload it to the canvas. And the ggplot function, at first data, then so-called aesthetics. So we specify what is X, what is Y, and since we have the 3 groups, the parties, that we have the 3 so party identification, so that we have to specify group. And then the color and the linear type, line type, then we specify the line plot, the GEOM line, then we can make the ggplot. We need the positive sign here. Then we can make this graph. So we differentiate color and the educational level is here. So usual plot function cannot generate the line graph for categorical variables. Actually, it can create, but we cannot put the name of the categories here. So original plot function only recognize this as 1 to 7. So the ggplot function is convenient in this sense. So next plot is the income level. Actually, the income, so the typical value of the income in the class and the proportion of the Democrats and Independent and the Republican. So yeah, so it's not clear trend, but still the Democrats, if the income is lower, then the more people that support the Democratic Party. And the Republican maybe slightly higher percentage when income is higher, maybe. And the Independent, not much tendency, slightly higher for higher income, but around here it's really big. So this can be made by the matplot function. So the making a contingency table and take the proportion. So that is the same as the previous one. But here the income is the numeric variable. So it's a little easier to create a graph. So the matplot function makes this graph at once. So this is the x values and this is y value. But these have the 3 columns. Democratic and the Independent and the Republican, and we can make it at once. So it's a convenient function. And then the legend. So we have to specify the location and all the specifications. So it's a little inconvenient, but then we can get this. Yeah. So so these are the demonstration of the data set. So in the next video, we fit the multinomial Logit model.